One of the areas where people get the most confused with fractions is in dealing with division. But division really isn't anything hard if we actually understand what fractions are. So let's break up this mystifying aspect of fractions. There, clear, right? Of course not. Like most other students, when you see this, your brain just sees, okay, I've got a bunch of letters, the same letters, some dots in the middle. It kind of all looks the same. It's not at all clear what's going on or why it's going on. We can understand this if we just pause to think about what the operations are. Let's consider 6 minus 2, 6 plus negative 2, and 6 minus negative 2. When I see 6 and then back up 2, I see how this is taking that 2 from forwards, moving it backwards. Here my plus is still a plus, but the 2 is negative, so it's going backwards. Those are meaning the same thing, but I've changed the operation. Here is where we're going to understand dividing fractions. When I reverse the direction of this negative, that minus 2 switches around, becoming a plus 2. Because I'm reversing the reverse. I'm adding the opposite of negative, which is positive. It works the same way with fractions. 6 minus 2, that's like 6 divided by 2. My 6 is being shrunk down to half the size. 6 plus negative 2, that's like 6 times half. It's the exact same situation, but displayed using multiplication reciprocal instead of dividing by the original number. Well, that means 6 divided by 1/2. I'm shrinking it by a shrinking factor. This is the same as the minus negative. I'm shrinking, so that means I'm multiplying by 2. It's reverse here, meaning left to right. This is reverse here, meaning shrink, unshrink, so to speak. The problem with most fraction teaching is we're starting with fractions instead of starting with actual numbers, meaning unit fractions and whole numbers. So when we have something like 6 divided by 1/2, people do silly things like put that 6 over a 1. Of course we know 6 is 6/1. We don't need to fit this into some silly formula. We need to understand that dividing by 1/2 is multiplying by the reciprocal of 1/2. Well, what's the reciprocal of 1/2? What do I multiply by 1/2 to get 1? 2. Now we can show this visually. We can show on the number line. If I do 6, let's do both of these at the same time. Those look like they're about the same length. If I do 6 divided by 2, okay, how many 2's make into 6? Well, here's 1 2. I'm not there yet. Here's another 2. I'm not there yet. Here's another 2. Oh, there I am. How many 2's did I have? 1, 2, 3 pairs of 2's. In other words, 2 times what gets me to 6. How many 2's do I need? I need 3 2's to get to 6. Well, I can line these up the same here. Let's look at 6 divided by a half. How many halves do I need to get to 6? Well, 1 half, 2 halves makes a whole, 3 halves, 4, 5 halves, 6 halves gets me to 3, 7, 8, 9, 10, 11, 12 halves gets me to 6, right? Or half of 12 is 6. In other words, 6 times the reciprocal of a half, 6 times 2, there's my 12. Now, once I move away from unit fractions to fractions that have an actual numerator and denominator, that's more like the subtraction problem. Let's just pick some numbers here. I am doing 6 minus 5, but then I'm subtracting the opposite of 3. I'm adding 3. I could say 5 minus 3 is 2. So I've moved forward 6, and then I moved backwards 2. I've moved backwards 5. Nope, I cut off 1, 2, 3 of those 5. I only moved backwards by 2, so I'm at 4. There's my illustration of 6 minus 2, which is 4. That's an ugly 3 there. Or I could move forward 6, back up the 5, the full 5, to 1, and then from 1, I'm going to add 3. 1, 2, 3. And 1 plus 3 is 4. Right? This is the same as that. And if I can do 5 minus 3 to get 2, great. If I can't, let's say there's an x here. Well, I can't subtract 5x from 6, but I do know the opposite of negative, the opposite of subtracting, the opposite of negative gives me a plus here for the 3. So 6 plus 3 is 9 minus 5x, right? If I do that plus 3 first, 6 plus 3 is 9, and then 9 minus 5, 1, 2, 3, 4, 5, brings me back to the 4, if the x weren't here. Right? This idea where the subtraction applies to the positive as subtraction and applies to the negative as the reverse of subtraction as addition helps us to understand fractions, fraction division. Right? Let's say I have 6 divided by 5/3. Well, written the same way I have up here, that's 6 divided by 5/3. 5 divided by 3. 6 is being divided by 5. 6 over 5. That's 6 is over the 5. But just like minus negative gives me plus, that's an underline, not a dash here. Minus negative gives me plus. Divide gives me times. I'm undoing that division. Okay? Dividing by 1/3 gives me 3. Just like in the previous screen, dividing by 1/2 is really multiplying by 2. 6 is still just 6 though. I'm starting at 6. And then I'm dividing by 5/3. I'm multiplying by its reciprocal, 3/5. I'm dividing it by 5, and then counting 3 of those. Here we have 3/5 of 6. How many times does 5/3 go into 6? Well, wherever this is on the number line, looks like a little more than 3. There's my answer. How can we finish this problem out? Well, I could factor 6, but nothing cancels. I have 3 times 3, not 3 divided by 3. So 2 times 3 is 6, 6 times 3 is 18. There's 18/5. So I can count by fifths. 1, 2, 3, 4, 5/5. 6, 7, 8, 9, 10/5. 11, 12, 13, 14, 15/5. Why am I counting 5, 10, 15? Because 5/5 is 1, 10/5 is 2, 15/5 is 3, 16, 17, 18/5. So it's 3/5 past 3. So I have 3 and 3/5. In other words, 18 is 3 more than 15, but we haven't gotten into adding fractions yet, so kind of going a little out of order here, right? 15/5 is 3, 3/5, 3 and 3/5. But most of the time when we're multiplying or dividing fractions, we'll just leave it just like that. The only time we need to switch to a mixed number is either if the problem just tells us to, we have to follow the directions, or when we're using a number line, right? If I actually put a real scale on here, recognizing that this is a little more than halfway between 3 and 4, it's easier than saying it's 18/5. It's hard to spot 18/5 on a whole number line. And the third reason is, besides graphing, is just regular estimating, even if I'm not drawing the picture. But for these problems, we're not estimating, we're getting the exact answer. And when I throw in signs there, it doesn't make any difference. So let's say negative 2/3 divided by 17/12. Well, negative 2/3 doesn't have anything in front of it except for a negative. Dividing by 17, I can show that as 1/17. Dividing by a 12th, dividing cancels. That means multiplying by 12. Right? Whatever's coming after this division symbol, when we show that as like plus the opposite, when we show that as times the reciprocal, we get the reciprocal of what's coming after that. Right? So how many negatives do I have here? Just one. My answer is going to be negative. I could do 2 times 12 is 24, but I recognize 12 is 3 times 4, and so those 3's cancel out. 12 divided by 3 is 4. 4 times 3 divided by 3, right back to 4. Now I could have written 12 as 2 times 6, but I don't have a 2 or a 6 in my denominator for which to cancel. So I'm being strategic in which factor pair I use. I could go the full way, write 12 as 2 times 2 times 3. But then I'm going to have more to multiply, right? 2 times 2 is 4. I already had the 4 here. So I'm being strategic. I want to cancel the 3. I show 3 as a factor, so it cancels. 2 times 4 is 8. Come on, 8. And then 17 there stays as 17. And that negative, that's it. If I had another negative floating around here, two opposites make a positive. If there's a third negative, if they did something dumb like put negative 17 over negative 12, reverse, those cancel. We're left with an extra negative. So we're back to negative, not an equal sign, negative 8/17. Right? There's no mystery about the negatives. here, whether it's a fraction or a whole number or several whole numbers. It's really all multiplication here. So the sign rules work the same way.